Science.
Dark matter is one of the deepest mysteries of the universe. No one can see it, but scientists know it exists. It's the glue that holds the universe together, and now NASA scientists report that hints of dark matter may have been detected in the alpha magnetic spectrometer of the ISS. But they can't conclusively say whether this is the proof they're looking for. Maybe the answer will be revealed by the DarkSide 50 experiment being carried out in this underground laboratory, built underneath the Gran Sasso mountain in Italy.
Without dark matter, the universe would not be like it looks today. The amount of matter, which is heavy and slow, would have been insufficient without dark matter to accrete the clusters of galaxies and ultimately to form the universe that we know today. So it's a fundamental intellectual question to be addressed to understand the origins of our system and the evolution of the universe.
At the Gran Sasso National Laboratory, engineers are preparing a metal sphere 4 meters in diameter with 110 expensive light-detecting devices called photomultiplier tubes. These devices are called scintillators and are able to capture the slightest light emission and turn it into an electronic signal that can be computer analyzed.
This is a very crucial phase. During these days we are installing the photomultiplier tubes that are optical sensors that will detect the light produced here in a liquid scintillator and convert the light into an electrical signal that can be processed by our electronics and also later on also processed by our data analysis.
The sphere is assembled inside a cylinder 11 meters wide and 10 meters high, which contains 1,000 tons of water, in order to isolate it even more from cosmic radiation. This sphere will also contain a small capsule filled with 50 kilos of liquid argon, a rare naturally depleted gas that is found deep underground. In its liquid form at minus 180 degrees Celsius, it can emit light and release electrons when hit by other particles.
Argon is the most important part of the project because it's the target material. What it means, it offers two means of detecting ionizing radiations, whether it's from radioactivity, natural radioactivity, or it's from dark matter.
Because dark matter is made of weakly interacting massive particles, and because liquid argon is extremely reactive to particle impacts, if dark matter particles hit 1 or 2 argon particles, then because argon can emit light and release electrons when hit by other particles, scientists should be able to record the phenomenon and therefore prove that dark matter exists. The project is funded by a panel of European, US and Chinese institutions and is expected to run for 3 years.